Sensor is one of many input sensors that the computer uses. It uses the sensors and then it commands like an output, for example, like the fuel injection system or the ignition system. If we'd have a bad camshaft sensor, well, for example, here's one right here. Now, if you look at this, it's really pretty basic. This is a magnetic sensor, and the way this works is real simple. Now, this is a two-wire sensor. There's two wires to the sensor itself. But there's a trigger wheel on the camshaft. Either you'd be on a camshaft gear, it could be on the camshaft itself. As that reluctor comes around, it breaks the magnetic field, and that input is sent to the computer so the computer knows where the camshaft is. Now, this is the crankshaft sensor. Now, if you look at it, they look totally different in design, but they basically do the exact same thing. It's also a magnetic sensor. Now, the information from the crankshaft sensor, for example, would be used to tell it where each one of the different cylinders are in accordance to like the compression stroke where it's going to fire the ignition system. We have a third sensor. This looks a lot like it as well. It's also a magnetic sensor, but this is a vehicle speed sensor. This actually sends a pulse to the computer to let the computer know how fast the vehicle is going. So there's three sensors there, but then we get into a couple of different ones I want to show you. For example, these are both temperature sensors. The computer needs to know what the coolant temperature and also the intake air temperature is. This is a coolant sensor, and if you look at the tip, this would be in the coolant stream. When the engine's cold, naturally it needs more fuel, and this is one way that the computer knows where the engine temperature is. As the engine warms up, it needs to have less fuel, and that's where this also comes into play. The incoming air for the engine, if you look at this, this looks a lot like the coolant sensor, except the thermistor on this is actually exposed. It's right there inside this cage. The airstream actually goes past the thermistor and tells the computer what the intake air temperature is. We have another sensor, and this is used on some vehicles. This is a mass airflow sensor. And what this does, all of the incoming air it takes to run the vehicle goes through the sensor. This is very important for the fuel injection. A lot of times with this sensor here, it's something else you'd want to check if you had trouble code for this. This sensor would be the air ducting going to it, because if you had a crack in the air ducting, naturally the airflow rate is going to be different. Two of the most common sensors that you're going to find and have a problem with, one is going to be the O2 sensor or the oxygen sensor. The reason for that is the O2 sensor, the tip of it, actually goes into the exhaust stream. What its job is to monitor the amount of oxygen in the exhaust system. If there's a lot of oxygen, it tells the computer that the engine's running too lean. If it has less oxygen, it's running too rich. So the computer's constantly monitoring this. This is a fuel control device. Now, the thing of it is if you have an O2 sensor code, just don't automatically replace the sensor. There's other things that can cause the code to appear. This is not a real inexpensive item. Something else to keep in mind is some vehicles can have up to 6 O2 sensors on it. The front ones are going to take care of the fuel control, but then you have the others in line. Another sensor we have to show you, this is called a TP or a throttle position sensor, and this is a very important sensor, and these have a lot of problems because it is in fact a mechanical sensor. This actually hooks to the throttle shaft. Now the screwdriver would represent the throttle shaft either on the carburetor or on the fuel injection unit. There's a resistor inside of here, and as this rotates, it actually sweeps past that resistor, and that value is sent to the computer to basically let the computer know where the throttle angle is. And this is really easy to check off of the car. Let me show you how to do that. Basically, all we really need is a digital volt ohm meter, and we're going to use the ohm circuit. And what we want to do is just actually check the resistance of the sensor itself. Let me get this set up here, and then I'll show you what I'm doing. Now, this is a 3-wire sensor, and what that basically is, it's going to have voltage, ground, and then the signal return from the sensor. So I've got the 2 leads hooked up to it. We'll connect them to our DVOM. There we are. Make sure everything's separated. We'll put this on our ohm scale. And what I want to do, I want to just basically take the screwdriver, put it in where the shaft's going to go, and I want to watch my DVOM as I turn the TP sensor. Now what I'm looking for is a smooth transition from all the way at idle to wide open throttle. And I'll tell you what, this sensor here has got a bad spot right off idle, about right there. And what you'll see on the DVOM, you'll actually see where the ohm reading will go open, like an open circuit. And that's what you want to look for. Now what this will do is, if you've ever had a problem with a TP sensor, what it'll do is you'll have like a flat spot and almost like a bad accelerator pump on a carburetor. So like you're at idle right there, and as soon as you touch the idle and get off idle, That's where this is open right there. So what that would do is, at that instant, the computer doesn't know where the throttle angle is. So it has to try to compensate for this sensor. If you have a fault code for a sensor, there's a couple different easy ways to check this, and then there's the most common problems, like for example, this would be the sensor itself. As with any job, to do it right, you'll need the right tools. The nice thing is that jobs today don't require a large, expensive assortment. Basic hand tools are generally all you'll need. In case where a specialty tool is required, be sure to check with AutoZone's Loan a Tool program. They have many specialty tools that can help you complete your job a lot quicker and easier. The first things you'll need are a socket set and a repair manual for your specific vehicle. You may also need screwdrivers or pliers to remove some components.
Be cautious when working under the hood. If the engine has been running, components will be extremely hot, so be careful what you touch. When working around a running engine, it is important to be alert and never wear loose clothing or a necktie that can get tangled in belts, pulleys, or the fan. If you have to lift the vehicle, never work under it until it has been secured with wheel blocks and securely positioned on jack stands. A hydraulic jack alone is never enough. And always remember to wear your safety glasses. Get the entire DVD for this repair and all other procedures covered in the Complete Car Care series at your local AutoZone store.